Welcome to the fourth video of Safe Human Detection in a Collaborative Work Cell training package. In the previous video, we learned how to connect a safety laser scanner to a robot controller, and in this video we will learn how to configure the device and its safety areas using a configuration software. The configuration software is a manufacturer-specific software that is used for configuring equipment from the manufacturer. The software includes interfacing for safety and warning zone configurations and also standard input-output or I/O assignments such as reset and standby functions, and they usually come with customizable I/O assigning possibilities and also possibilities for altering device or project information. The software also has functionality for project commissioning and is usually automatized within the software. Examples of configuration software are SIG CDS, which stands for Configuration and Diagnostic Software, or Builds PSE and Scan Configurator. The following slideshow demonstrates the configuration process of a SIG S300 mini-series laser scanner using the SIG Configuration and Diagnostic Software, or CDS. The rundown of the demonstration is that first we interface the computer with the to-be configured equipment, and second we do the actual device configuration, and third we do the uploading of the project to the device, or we commission the project. We will start by interfacing the configuration PC with the configured equipment, and the first thing we should do is to connect the scanner to a configuration PC using the accompanied M8x4/USB configuration cable. And next we start the configuration and diagnostic software on the configuration PC. And please note that the scanner does not yet appear on the list of devices, as it needs to be identified first. To identify the scanner, we click on the Identify Project button in the toolbar. And after the Select Connection interface pops up, we select the correct communication port, which in our case is COM4, and then we click Identify. And if in your case the port is not known, then you should select all the ports and then click Identify. The connected device appears automatically in the list of connected devices. So now the scanner has now been correctly identified, and it has automatically been added to the list of connected devices. And then we double click on the scanner name on the list to open the device configuration window. On the picture on the left, we see the device configuration window. In the window on the left side, there is the configuration and diagnostics menu, which is used to configure the device. And in the top bar, we see the functions for data transfer and the user login. And we should go through the configuration menu in order to fully configure the device. And the first place we should look for is the System Parameters window. In the System Parameters window, we can give our application and device and user group a suitable name for our application, and we can also select whether our 7-segment display on the scanner itself should be rotated by 180 degrees. And when we are done here, we can click on the resolution/scanning range in the sidebar. Here we can select whether we are using the device in a stationary or mobile application. In our case, we are using it in a stationary application. Next, we can choose the desired scanning resolution. The software automatically calculates the response time and maximum range of the protective field, and in our case 70 millimeters, which is suitable for leg detection, is accurate enough, which gives us a good 3 meters of maximum protective field range. Next, we should go to Universal I/O on the sidebar. In the Universal I/O window, we can assign the inputs and outputs for our application. And in this particular scanner, there are only two input-output pins available, and they have been wired as standby and reset inputs. They could be wired as external device monitoring inputs or outputs for lens contamination, error and warning, or for a second warning field violation, and also device error output. The software automatically displays the correct wire coloring for a manufacturer-provided cable or OEM cable. And after we are done here, we can click on the OSSDs in the sidebar. In the OSSDs window, we may toggle whether the OSSD should be triggered by an object in the protective field, which is by default true. And in this window, we can also configure whether the external device monitoring function is active, and provided it has been wired and assigned so in the previous window, the Universal I/O window. This may be useful when performing diagnostics or testing the application when commissioning the project. And after we are done here, we can click on Restart on the sidebar. In this Restart window, we may set the desired behavior for restart interlocking. And the default options are without restart interlock, with restart interlock, and delay by a number of seconds. When the restart interlocking is active and the scanner has detected a protective zone violation, the scanner requires a reset signal by a human operator to return back to its normal or operational state. When the restart interlock is inactive, this reset is automatically performed and no interaction by an operator is required. The restarting can be timed also with the delay option, which stands for a specific number of seconds when there are no new protective zone violations. And after that, we can move on to the field sets. And here we can see the graphical interface that is used to draw or design the protective and warning zones into the project. The scanner is represented by the gray icon in the grid line origin. And in our application, this scanner is used for doorway monitoring, and the entire area should be monitored by a protective field, which is what we have drawn here. And after that, we can move on to cases. And as for the cases window, some scanners support multiple monitoring cases, which are switched via a specified signal input or foreign object speed data from other devices when the configured device is used as a guest device. And in this window, a field set may be assigned to a different monitoring case if multiple monitoring cases are supported. And this means that these field sets can be changed on during normal operation based on the signal input or the speed data from other devices. And after these have been configured, we can move on to simulation on the sidebar. And in the simulation window, we can simulate different monitoring cases that we have configured in the previous window. This simulation can be used as a part of the verification or project commissioning process if multiple monitoring cases are supported and they have been configured. This works by toggling the input conditions on the left side of the screen based on a simulated signal input or simulated speed data from other devices. And after we have done the simulation, we can go to verify our project. And we should do that by clicking on the Data Recorder button on the sidebar under the Diagnostics tab. And in this window, we can see the live data that is being broadcasted by the scanner based on its surroundings. And this data can be used for adjusting the field sets if they need to be adjusted. And this is a great way to compare your safety zone design with the actual environment, and can be used for example, when monitoring a doorway for leaving some contouring between the protective zone and actual physical obstacles in order to prevent false triggering from the laser scanner. On the picture on the left, we can see the live scanner data during normal operation. The center line spike comes from the connection cable, and as we know that it can be safely ignored as part of the evaluation process. On the picture on the right, we can see a worker attempting to access through a monitored doorway, and as a result, a protective zone violation is detected, and the scanner OSSDs are set off, which effectively stops the robot or monitored device. At this point, based on the data that we saw on the data recorder, we can say that our configuration works as intended, and the project is essentially completed at this point. What's left to do is to transfer the configuration itself onto the scanner. And on the CDS software, this can be done by clicking on the Transfer to Device button on the toolbar. This causes the project to be transferred to the scanner through the configuration port or communication port, and which causes the scanner to reinitialize, and after the scanner has restarted, it deploys the project automatically. And at this point, the configuration has been transferred to the scanner, and the scanner is now fully operational. This video concludes the training package for module Safe Human Detection in a Collaborative Work Cell. Thank you for participating in our training.